Have you ever had that feeling, like something's just off? Not in a dramatic way, but in the quiet moments. Maybe you've noticed the trees in your neighborhood blooming at weird times, or the birds acting strange, or you're scrolling through the news, and every headline feels like it's screaming unprecedented and never seen before. And somewhere deep down, past all the daily distractions, there's this little voice asking, "Are we missing something important here?" You're not imagining it, and you're definitely not alone. There's this thing that happens before big shifts, before earthquakes, before storms, before those moments when everything changes. Nature starts whispering warnings. Animals behave differently. The air feels different. Your grandmother might have called it feeling it in her bones, and here's the thing, she wasn't wrong. What we dismissed as superstition, turns out it might be pattern recognition we've forgotten how to hear. We're living through something right now. Multiple crises stacking on top of each other like dominoes in a circle. Climate chaos, economic fragility, systems breaking down in ways we've never seen before. And the wild part, they're all connected, each one affecting the others in ways we're only starting to understand. So here's what I want to do. If this resonates with you, if you felt that same unease, help this reach others who might be wondering the same things. A small like helps this video find kindred spirits who are also paying attention, who are also asking questions. Because we've got a long journey ahead, about an hour and a half together, and your support means this can reach the people who might need to hear it. For the next 90 minutes, we're going to explore 15 signals that something bigger might be shifting. We're going to look at supervolcanoes and microplastics, at collapsing ocean currents and failing antibiotics, at the soil beneath our feet and the asteroids above our heads. But we're not doing this to panic. We're doing this to see clearly. So, find a comfortable spot. Maybe grab some tea, a blanket, whatever makes you feel settled. There's no need to hurry. We'll take our time with this. We're going to sit with uncomfortable questions, look at what's actually happening, and maybe, just maybe, figure out what we're meant to do with this information. Because if humanity's about to reset, and I mean if, then the signals are already here. We're just not looking in the right places. Let's start paying attention. You know that feeling when something's off, but you can't quite put your finger on it. Like when you walk into a room and sense the mood has shifted, even though no one said a word yet. Nature has that feeling right now. And it's trying to tell us something. On December 26, 2004, something strange happened in Sri Lanka. About an hour before the tsunami hit, elephants started breaking their chains. They weren't panicking, exactly. They were purposeful, deliberate. They headed for higher ground, and they took some tourists with them. Those elephants saved lives that day. Here's the thing, we still don't fully understand how they knew. Scientists think it might be infrasound, vibrations too low for human ears to detect. Or maybe they felt subtle changes in the ground. But whatever it was, they picked up a signal we completely missed. And they acted on it. This isn't a one-time story. Before the 2011 earthquake in Japan, catfish became unusually active. Before earthquakes in China, snakes have abandoned their hibernation in winter, freezing to death rather than staying underground. Birds go silent. Dogs refuse to enter buildings. It happens so reliably that researchers have catalogued it across cultures and centuries. The pattern's clear. Animals are reading something in the environment that our instruments often catch too late, or miss entirely. Now, you might think, sure, but we have technology now. We don't need to watch animals. And that's partly true. Our seismographs are incredible. Our weather satellites are sophisticated. But here's what makes you pause. Sometimes traditional knowledge beats our billion-dollar systems. Take indigenous communities in Australia. For thousands of years, they've predicted weather by watching when certain flowers bloom, when specific birds migrate, or how ants build their mounds. For a long time, Western science dismissed this as folklore, superstition. But recently, meteorologists started actually testing these methods. And they work. In some cases, they're more accurate for local conditions than computer models. There's a reason for that. These observations aren't superstition. They're pattern recognition refined over thousands of years. When your survival depends on reading the environment, you get very good at it. You notice things. Small things. The kind of subtle changes that don't show up on a radar, but matter enormously on the ground. We've lost most of that literacy. We've outsourced our attention to screens and sensors. And maybe that's fine most of the time. But what about when the sensors are wrong? Or when they're measuring the wrong things? Let's talk about those unprecedented weather events you keep hearing about. That word, unprecedented, is showing up a lot lately. Unprecedented floods. Unprecedented heat waves. Unprecedented droughts. Unprecedented fires. Statisticians are starting to get uncomfortable with how often we're using that word, because unprecedented is supposed to be rare by definition. When the unprecedented becomes routine, something fundamental has shifted. Here's what they're seeing. Events that should happen once every 100 years are now happening every few years. The models we use to predict weather, models built on decades of historical data, are becoming less reliable. It's like the rules have changed, but we're still playing by the old playbook. And it's not just the weather. There's something else happening that doesn't make headlines, but probably should. The Earth's magnetic field is weakening. Has been for about 200 years now. It's lost about 9% of its strength, and in some places, like the South Atlantic, it's weakening much faster. Now, before you panic, this is normal. The magnetic field has flipped before. North becomes south, south becomes north. It's happened hundreds of times in Earth's history. The thing is, it usually takes thousands of years. And we're not sure if we're heading for a flip now, or just a temporary weakening. Scientists genuinely don't know. But here's why it matters. That magnetic field protects us. It shields the planet from solar radiation. It's why our electronics work. It's why satellites stay functional. If it weakens enough or flips, we could see serious disruptions to power grids, GPS systems, communication networks. The things we depend on most are the things most vulnerable to this invisible change. You probably won't feel it directly, but your phone might stop working. Your bank's computers might glitch. Aircraft navigation could fail, and we wouldn't have much warning. Let's bring this back to something personal. Your grandmother ever say she could feel it in her bones when rain was coming? Maybe you rolled your eyes. I probably would have. Turns out she might have been onto something. Changes in barometric pressure really do affect the body, especially joints. People with arthritis report increased pain before storms with measurable accuracy. That's not mysticism, it's physiology. Their bodies are detecting atmospheric changes before those changes become obvious. So when your grandfather said, "Storm's coming, I can feel it," he wasn't being poetic. He was reading a signal. A real physical signal that he'd learned to interpret through experience. We've become so reliant on being told what's happening that we've stopped noticing what's actually happening. We check the weather app instead of looking at the sky. We trust the news to tell us what's important instead of trusting our own observations. And maybe that's why we keep being surprised. Surprised by disasters that, in hindsight, had warning signs everywhere. We just weren't looking. Or we were looking at screens instead of the world. The signals are there. Animals picking up on vibrations we can't hear. Traditional knowledge revealing patterns our models miss. Statistical anomalies suggesting the rules have changed. Invisible fields weakening. Bodies responding to atmospheric shifts. It's all connected. And it's all trying to tell us the same thing. Something's changing. The baseline's shifting. And we need to start paying attention to the signals we've been trained to ignore. Not because it'll solve everything, but because the first step to navigating change is recognizing that change is happening. And right now, we're still pretending everything's normal. That these are just isolated incidents. Random bad luck. But pattern recognition, whether it's elephants heading for high ground or your bones aching before a storm, that's not about individual events. It's about seeing the bigger picture. And the bigger picture is starting to look different than what we expected. So maybe it's time we started reading the signals again. Not with fear, but with attention. With the kind of awareness our ancestors took for granted. Because the world is always sending us information. We've just forgotten how to listen. And that's the unsettling thing, isn't it? We're receiving signals from all directions now. Not just from nature, but from our own systems. From the economy. From supply chains. From global health. And here's what makes this moment different from any other in history. These signals aren't coming one at a time anymore. They're arriving all at once. Welcome to what researchers are calling the polycrisis. It's not a word that rolls off the tongue, but it describes something you've probably been feeling for years now. That sense that everything seems to be breaking simultaneously. That it's not just one problem anymore, but a dozen problems, all tangled together, all making each other worse. Think about dominoes for a second. Normally, when you set up dominoes in a line, you know exactly what'll happen. One falls, then the next, then the next. Simple cause and effect. But now, imagine those dominoes aren't in a line. They're arranged in a circle, some standing close together, others connected by threads you can't quite see. When one falls, you don't know which direction the cascade will go. You just know they're all coming down. That's where we are. The pandemic showed us this in real time. COVID-19 wasn't just a health crisis. Within weeks, it became an economic crisis. Then, a supply chain crisis. Then, a mental health crisis. Then, a political crisis. Each one triggering the others, amplifying the damage, creating problems nobody had planned for because nobody imagined they'd all happen at once. Remember when you couldn't find toilet paper? That wasn't because there was a toilet paper shortage. There was plenty of toilet paper. The problem was that supply chains are built for efficiency, not resilience. They're designed to deliver exactly what's needed, exactly when it's needed, with almost nothing held in reserve. It's called just-in-time delivery, and it works beautifully until something disrupts the timing. Then the whole thing collapses. One factory shuts down in China, and suddenly there's no car parts in Detroit. A ship gets stuck in the Suez Canal, and shelves go empty in London. A pandemic hits, and suddenly we realize that we don't actually make most of our medications domestically anymore. We've outsourced our resilience for the sake of cheaper prices. But here's where it gets more complex. The supply chain issues didn't happen in isolation. They collided with something else that was already breaking, the global food system. You might not have heard about the fertilizer crisis. It didn't make as many headlines as empty store shelves or rising gas prices. But it's one of those quiet catastrophes that could reshape everything. Modern agriculture runs on synthetic fertilizer, and most of that fertilizer is made from natural gas. When energy prices spiked, fertilizer prices followed. In some places, they tripled. For farmers operating on thin margins, that's devastating. Some simply couldn't afford to fertilize their fields properly, which means smaller harvests, which means less food, which means higher prices, which means more people going hungry, which creates political instability, which disrupts more supply chains. See how it compounds? And all of this is still rippling from decisions made decades ago. The 2008 financial crisis, for instance. You might think we recovered from that. Stock markets went back up. Banks stabilized. Life went on. But underneath, the damage never really healed. Governments responded by printing massive amounts of money and keeping interest rates artificially low. That created asset bubbles. Housing became unaffordable. Wealth, inequality, exploded. And now, when the next crisis hits, we've already used up most of our economic ammunition. It's like trying to fight a fire when you've already emptied half the water tank, putting out the last one. The uncomfortable truth is that our systems were designed for a more stable world. A world where problems came one at a time, where you could fix one thing before the next thing broke. But complexity has consequences. The more connected everything becomes, the more one failure cascades into everything else. Climate change doesn't just mean hotter summers. It means droughts that devastate crops, which spike food prices, which trigger protests, which destabilize governments, which disrupts trade, which creates refugee crises, which strains neighboring countries, which inflames political tensions. Every thread pulls on 10 other threads. And we're not good at thinking this way. Our brains evolved to handle immediate, visible threats. The lion in the bushes. The stranger with a weapon. Not this web of slow-moving, interconnected crises where cause and effect are separated by years or even decades. That's why the polycrisis feels so overwhelming. Because it is. Because it's designed to be. Not by any conspiracy, but by the simple mathematics of interconnection. The more complex a system becomes, the more ways it can fail. And when it does fail, it doesn't fail cleanly. It fails in cascades. So what do we do with this information? How do you prepare for everything breaking at once? The honest answer is, you can't. Not completely. But you can start seeing the connections. You can recognize that when one system shows signs of stress, others are likely stressed too. You can build some redundancy into your own life. Learn skills that don't depend on complex supply chains. Know your neighbors. Understand where your food comes from, where your water comes from, what happens if the grocery store runs out. Because here's the thing about dominoes in a circle. Once they start falling, you can't stop them all. But if you're paying attention, you can step back before they reach you. You can create some space, some buffer, some breathing room. The signals are there. The connections are visible if you look for them. Individual crises are bad enough. But when they start compounding, when they start feeding into each other, that's when the real danger begins. And right now, they're compounding. Because here's the thing about compounding crises. Sometimes they're all pointing towards something we've been living on top of all along. You know Yellowstone National Park, right? Hot springs, geysers, Old Faithful doing its thing every 90 minutes like clockwork. Beautiful. Peaceful. Millions of visitors every year taking photos of bubbling mud pots and steaming pools. What most of those visitors don't realize is they're walking on top of one of the planet's largest active supervolcanoes. And before you think I'm being dramatic, let's talk about what a supervolcano actually is. It's not a mountain. It's a crater. A collapsed magma chamber so massive that when it erupts, it doesn't build a cone. It just opens. The Yellowstone caldera is 45 miles across. Underneath it, there's a plume of molten rock rising from deep in the Earth's mantle, pooling just a few miles beneath your feet. Scientists have a technical definition for supervolcanoes. They measure eruptions using something called the Volcanic Explosivity Index. Regular volcanoes might rate a 4 or 5. A supervolcano eruption is an 8. And the difference between a 5 and an 8? That's not linear. That's exponential. We're talking about eruptions 1,000 times more powerful than Mount St. Helens. So, what actually happens when one of these goes off? First, there's the blast itself. Yellowstone's last major eruption was about 640,000 years ago. It ejected about 240 cubic miles of rock and ash into the atmosphere. For context, that's enough material to bury the entire state of Texas under 5 feet of debris. The explosion would be heard across the continent. The shockwave would flatten forests for hundreds of miles. But that's just day one. The real problem is what comes next, the ash. Within days, a blanket of volcanic ash would cover most of North America. We're not talking about the soft gray stuff from a fireplace. Volcanic ash is tiny fragments of rock and glass. It gets into everything. It clogs engines, grounds aircraft, contaminates water supplies. If you breathe it, it turns to cement in your lungs. Then comes the volcanic winter. All that ash and sulfur dioxide in the atmosphere, it blocks sunlight. Global temperatures drop. Crops fail. We've seen smaller versions of this before. When Mount Tambora erupted in 1815, the following year was called the year without a summer. There was snow in July in New England. Crops failed across Europe. People starved. Now, scale that up. A Yellowstone eruption wouldn't give us one bad year. We'd be looking at a decade of disrupted agriculture. Maybe longer. And here's where it gets really unsettling. About 74,000 years ago, the Toba supervolcano in Indonesia erupted. It was the most recent supervolcanic event we know of. Genetic evidence suggests that the human population crashed afterward, maybe down to just a few thousand breeding pairs worldwide. That's called a genetic bottleneck. We nearly went extinct. Now, we can't prove Toba caused that bottleneck. The timing lines up, but correlation isn't causation. What we do know is that supervolcano eruptions create the kind of environmental catastrophe that could absolutely crash a population. And back then, humans were nomadic. We could move. Today we've got cities, borders, infrastructure. We're a lot less mobile. So, should we be worried about Yellowstone? Scientists are watching it constantly. There's a whole network of seismographs, GPS stations, gas monitors. They're measuring ground deformation, literally tracking if the land is rising or falling. They're monitoring earthquake swarms. They're sampling gases escaping from hot springs. And here's what they'll tell you. Yes, Yellowstone will erupt again. Definitely. The question is, when? The caldera has erupted 3 times in the past 2.1 million years, roughly every 600,000 to 800,000 years. We're 640,000 years past the last one. But that doesn't mean we're overdue. Volcanoes don't work on schedules. The statistics are interesting, not predictive. What scientists look for are precursors. Before a major eruption, you'd expect to see certain warning signs. Massive ground uplift, like dozens of feet, not inches. Intense earthquake swarms, not just occasional tremors. Changes in the types of gases being released. None of those signs are present right now. Does that mean Yellowstone's not dangerous? No. It means it's probably not going to erupt tomorrow, or next year, or possibly for another 100,000 years. But it also means we wouldn't necessarily get a lot of warning. Some eruptions announce themselves months in advance. Others? Days. And even if we had months, what would we do? Evacuate half a continent? To where? And Yellowstone's not alone. There's Campi Flegrei near Naples, Italy. It's been showing increased activity lately. More earthquakes, more ground uplift. 500,000 people live directly on top of it. Then there's Lake Toba itself, still active. There are others around the Pacific Ring of Fire, under New Zealand, in South America. Living with a supervolcano is like living on a waterbed. Most of the time you forget what's underneath, until something makes it wobble. The uncomfortable truth is this: a supervolcano eruption is one of those low probability, high consequence events. It probably won't happen in our lifetimes. But if it does, there's no real way to prepare for it. No bunker deep enough, no stockpile large enough. It's a planetary scale disruption. So why talk about it at all? Because it's part of the larger pattern we're exploring here. These massive interconnected systems we depend on, climate, agriculture, infrastructure, they're more fragile than we like to admit. And whether the trigger is a supervolcano, or an asteroid, or just the slow accumulation of all those smaller crises compounding, the question isn't really what if. The question is what then? So what then? Well, here's something that should keep you up at night. On February 15th, 2013, the people of Chelyabinsk, Russia, were going about their Friday morning, commuting to work, dropping kids at school. Normal day. And then, the sky exploded. A meteor, about 60 feet wide, came screaming into Earth's atmosphere at over 40,000 miles per hour. It detonated with the force of 30 Hiroshima bombs. The shockwave shattered windows across the city. Nearly 1,500 people were injured, mostly from flying glass. And here's the terrifying part. We had zero warning. None. Not a single astronomer anywhere in the world saw it coming. The reason? It came from the direction of the sun, hidden in the glare. By the time anyone could have spotted it, it was already here. Now, you might be thinking, okay, but that's why we have all those asteroid tracking systems, right? And you're not wrong. We do have systems. NASA's got telescopes, scanning the sky. There's an entire planetary defense coordination office. But here's what they don't advertise on the glossy posters. We're only tracking a fraction of what's out there. Scientists estimate there are about 25,000 near-Earth asteroids larger than 140 meters, big enough to cause regional devastation. As of now, we've found and cataloged maybe 40% of them. That means 6 out of every 10 city-killer asteroids are completely unknown to us. They're out there right now, and we've got no idea where they are. And it gets worse when you go smaller. Objects like the Chelyabinsk meteor, house-sized rocks that can still level a city district, there are hundreds of thousands of them. We've probably found less than 1% of those. It's like trying to spot specific grains of sand on a beach while wearing a blindfold. The thing is, space is incomprehensibly vast and dark. And these asteroids don't exactly come with headlights. Most of them are darker than coal, absorbing light instead of reflecting it. Finding them requires looking at exactly the right patch of sky, at exactly the right time, and noticing something that wasn't there before. It's genuinely one of the hardest observational challenges in astronomy. But let's say we do spot one. Let's say tomorrow, telescopes pick up an asteroid on a collision course with Earth. 6 months out. What then? This is where NASA's DART mission becomes relevant. In 2022, NASA deliberately crashed a spacecraft into an asteroid called Dimorphos, just to see if we could change its orbit. And it worked. The impact altered the asteroid's path by 33 minutes, way more than the minimum they needed for success. For the first time in history, humanity proved we could actually move a cosmic object. That's the good news. The bad news? DART took years to plan and execute. We knew exactly where Dimorphos was, exactly where it was going, and we still needed years of preparation. If we only had 6 months warning of an actual threat, we'd be starting from scratch. No spacecraft ready. No tested protocols. Just panic and improvisation. And then there's the politics. Let's say we do manage to deflect an asteroid with 6 months' notice. We push it off course. Earth is saved. Everyone celebrates. But here's the question nobody wants to ask. What if deflecting it means it now hits somewhere else? What if our deflection sends it toward another country? Who makes that decision? Who gets to decide which part of Earth takes the hit? It sounds like science fiction, but it's a real problem. There's no international treaty for this. No agreed-upon protocol. If an asteroid's heading for New York, and the only way to deflect it sends it toward Beijing, who decides? And would they even tell anyone? The uncomfortable truth is, we're not prepared for this scenario, not practically, not politically. We've got better at spotting the big ones, the extinction-level threats. But the smaller ones, the city killers, they're still a cosmic lottery. Every single day, Earth is passing through a shooting gallery we can barely see. And unlike volcanoes or hurricanes, there's no pattern to predict. No season for asteroids. They just show up. Sometimes we see them coming years in advance. Sometimes Like Chelyabinsk, we don't see them at all until they're already exploding overhead. The people of Chelyabinsk were extraordinarily lucky. That meteor exploded high in the atmosphere. If it had been a slightly different size, slightly different composition, or hit at a slightly different angle, it could have impacted the ground intact. The entire city would have been vaporized. 1 million people gone. Because of a rock nobody saw coming. Space is like driving at night with your headlights off. You can only see what's right in front of you, and by then, it might be too late to swerve. We're getting better at turning on those headlights, slowly expanding our field of view. But the road is long, and there are a lot of things we still can't see. The question isn't really if another impact will happen. Impacts are a certainty over long enough timescales. The question is whether we'll see it coming, and whether we'll have enough time to do anything about it. Because right now, despite all our technology and all our telescopes, we're still mostly just hoping we get lucky. And hope, as it turns out, is not a great planetary defense strategy. Here's the script for part 5. But you know what's even more unsettling than space rocks we can't see? The invisible threads holding our entire civilization together, and how fragile they really are. Let me ask you something. Right now, wherever you are, look around. How many things in your immediate view require electricity to work? Your phone, obviously. Maybe your lights, your refrigerator, your heating or air conditioning. The router that connects you to the world. Now expand that circle. The traffic lights outside. The cell towers. The water treatment plant. The hospital down the street. The grocery store's refrigeration system. Everything, and I mean everything, runs on the grid. So what happens when it stops? We actually know the answer because it's already happened. February 2021, Texas. Not some distant doomsday scenario, but last year in a modern American state. A winter storm hit, temperatures dropped, and the power grid that serves nearly 30 million people just failed. It wasn't a terrorist attack. It wasn't a solar flare. It was cold weather and infrastructure that wasn't prepared for it. Within days, millions of people were sitting in their homes with no heat, no water, and no clear idea when it would come back. Pipes froze and burst. Hospitals ran on backup generators. Grocery stores couldn't refrigerate food. People burned furniture to stay warm. Over 200 people died. In Texas. In 2021. Because the electricity stopped. Here's what most people don't realize about our power grid. It's not designed for storage. Electricity has to be generated at the exact moment you're using it. There's no big battery keeping the lights on. It's a constant, real-time balancing act. And when that balance tips, everything cascades fast. Let's walk through what actually happens in a prolonged blackout, hour by hour. In the first few hours, it's almost exciting. Candles come out. People check on neighbors. There's a kind of camping at home energy. Your phone still works because it's charged. You've got food in the fridge. You tell yourself it'll be back on soon. By hour 12, things start to shift. Your phone's dying and you can't charge it. The food in your refrigerator is warming up. If it's winter, your house is getting cold. If it's summer, it's getting dangerously hot. You start to realize how much you don't know. Where's the nearest place with power? When will this end? Should you stay or should you go? By day 2, the real problems emerge. Hospitals are running on generators, but generators need fuel. Fuel pumps need electricity. You see the problem. Water treatment plants have backup power, but not forever. When those fail, the water stops flowing. Or worse, it keeps flowing but isn't safe to drink. Gas stations can't pump fuel. ATMs don't work. Credit card machines are useless. Cash suddenly matters again, but good luck finding any. By day 3, grocery stores have thrown out everything perishable. Supply trucks can't navigate because traffic lights are out, and communication is spotty. People start making harder decisions. Do you stay in your cold apartment or try to find somewhere warmer? Do you trust the water or risk dehydration? Do you share your supplies with neighbors or conserve what you have? This isn't speculation. This is what happened in Texas. This is what happens in Puerto Rico after hurricanes. This is what happens in California during deliberate shutoffs to prevent wildfires. We keep learning the same lesson, and we keep being surprised by it. Now, let's talk about something that could make Texas look like a practice run. The Carrington event. In September 1859, something extraordinary happened. The sun burped. A massive solar storm hit Earth, and the sky lit up with auroras so bright that people in the Caribbean thought the sun was rising at midnight. Telegraph operators got electric shock. Some telegraph systems kept working even with their power sources disconnected, powered purely by the electromagnetic energy flooding the atmosphere. Back then, the telegraph was the only electrical infrastructure we had. It was remarkable, but it was minimal. Today, we've wrapped our entire civilization in a web of electrical systems that are far more sensitive than a simple telegraph wire. If a Carrington-level event hit us now, satellites would fry. Power grids would overload. Transformers, those big metal boxes you see in neighborhoods, would melt. And here's the scary part. We don't have warehouses full of spare transformers. They're massive, expensive, and custom-built. Replacing them takes months, maybe years. Scientists estimate we have about a 10% chance of another Carrington event in the next decade. Those aren't comforting odds when we're talking about something that could shut down the power grid for months or years across entire continents. But at least a solar storm is an act of nature. At least it's not personal. Cyberattacks are personal. In 2015, hackers remotely shut down parts of Ukraine's power grid, leaving hundreds of thousands of people in the dark in the middle of winter. In 2021, a ransomware attack shut down Colonial Pipeline, causing gas shortages across the American Southeast. Not because the pipeline was physically damaged, but because the computer systems running it were locked. Our power grid isn't just old infrastructure struggling with weather. It's infrastructure connected to the internet, running on software, vulnerable to the same hacks as your laptop. Except when your laptop gets hacked, you don't lose heat and water and food refrigeration. The Department of Homeland Security tracks these attempts. They happen constantly, probing attacks, testing defenses, looking for weaknesses. Most don't succeed. Most. But it only takes one. Here's the uncomfortable question. If the grid went down for a month, how would you do? Not in theory. Actually. Do you have enough food? Water? Medicine? Medicine. Can you keep warm or cool? Can you cook without electricity? Do you know which of your neighbors are elderly or have medical equipment that requires power? Most of us, myself included, would struggle after about 3 days. Because we've built a world where the grid isn't just convenient, it's foundational. It's not an amenity anymore. It's life support. The electricity is invisible until it's not. We flip switches and things happen. We plug things in and they work. It's so reliable that we forget it's there. We forget that it's a human-made system requiring constant maintenance, constant vigilance, constant fuel. We forget that it can stop. The grid goes dark. That's not just about sitting in the literal dark. It's about everything that depends on that constant flow of electrons. It's about hospitals and water and food and communication and heat and basically everything that makes modern life possible. And the thing is, we don't need a solar superstorm or a sophisticated cyber attack. Texas proved that. Sometimes all it takes is weather we didn't prepare for and infrastructure we didn't maintain. So maybe the real question isn't whether the grid will fail. Maybe it's what we do about it while the lights are still on. And maybe that's the right segue into something even quieter, even harder to see. Because while we're worrying about the grid failing, there's another crisis happening. Not in the power lines. Not in the infrastructure. Inside you. Right now. As you're listening to this, there are tiny plastic particles in your bloodstream, in your lungs. If you're pregnant, they're in your placenta. If you're a parent, they're in your children. This isn't speculation. In 2022, researchers at Vrije Universiteit Amsterdam found microplastics in human blood for the first time. They tested 22 volunteers, found plastic in 80% of them. Polyethylene terephthalate, the stuff from water bottles, just floating there, in our blood. A few months later, another study found them in living human lung tissue. Deep lung tissue, the kind that doesn't just filter out with a cough. And then came the big one. Placenta study. Researchers found microplastic particles in every single placenta they examined. Every single one. These particles had crossed the barrier that's supposed to protect developing babies from the outside world. So, here's where it gets uncomfortable. We don't actually know what this means yet. The science is still catching up. But we're starting to see hints. And those hints aren't great. Your hormone system? It's basically a series of chemical messages. Tiny amounts of the right chemical, at the right time, tell your body what to do. Grow, sleep, bite, reproduce. It's incredibly precise. Plastics, it turns out, can interfere with those messages. They're called endocrine disruptors. They can mimic hormones, block them, change how your body responds to them. And because the doses that matter are so small, we didn't notice for decades. BPA was the first one people heard about. Remember when everyone started buying BPA-free water bottles? That was the beginning. But BPA is just one chemical. There are thousands of chemicals in plastic. We're only starting to test them. And then there are FOS, the forever chemicals, poly and perfluoroalkyl substances, if you want the full name. But everyone just calls them forever chemicals because that's what they are. They don't break down, not in any meaningful human time frame. They're in non-stick pans, waterproof jackets, fast food wrappers, firefighting foam. And once they're out there, they stay out there. In the water, in the soil, in us. The CDC has found FOS in the blood of 97% of Americans. They're linked to cancer, thyroid problems, immune system issues. But here's the thing that should really bother you. We're still making them. Still using them. Because the alternative would be expensive and inconvenient. Now, let's talk about something that's been quietly happening for decades. Sperm counts are dropping. Not just in one country. Everywhere researchers look. A meta-analysis published in 2022 looked at data from 53,000 men across multiple continents. Between 1973 and 2018, sperm counts dropped by more than 50%. That's not a typo. More than half. The rate of decline is actually accelerating. It was 1.6% per year before 2000. After 2000, 2.64% per year. Some of this might be microplastics. Some might be PFAS. Some might be other environmental toxins we haven't even identified yet. Pesticide, industrial chemicals. Things we thought were safe because we didn't test them long enough or carefully enough. But here's the really unsettling part. This isn't a crisis that announces itself. There's no alarm bell. No dramatic moment where everything changes. It's just gradual. One generation, slightly less fertile than the last. One generation with slightly more hormone disruption. Slightly more cancer. Slightly more autoimmune disease. It's like filling your gas tank with sugar, right? The car runs fine for a while. Runs normal. You don't notice anything wrong. But eventually, inevitably, the damage becomes irreversible. The engine seizes up. And by then, it's way too late to just drain the tank and start over. That's what might be happening to us. To our entire species. A slow motion collapse that's so gradual, we keep adjusting to it, normalizing it. Oh, fertility rates are dropping. That's just modern life. People are choosing to have fewer kids. Autism rates are rising? That's just better diagnosis. Now, cancer is more common. Well, people are living longer. Maybe. Or maybe we're watching something fundamental change in human biology, and we're just not connecting the dots. Because connecting the dots would mean admitting we've been poisoning ourselves for profit for half a century. And here's what makes it so hard to grasp. It's not like a volcano or an asteroid. Those are visible threats. Dramatic. Easy to understand. This is invisible. Distributed. Everywhere and nowhere at once. You can't stop using plastic. Not really. In everything. Your car, your phone, your clothes, your furniture. It's in the lining of cans. In tea bags. In the dust you breathe. Even if you went full zero waste tomorrow, you'd still be exposed. Because it's in the air now. In the rain. In the ocean. Microplastics have been found in Arctic snow. In fish in the deepest part of the Mariana Trench. There's nowhere left that's clean. So what do you do with information like that? How do you live with knowing you're carrying around plastic particles in your organs, and there's basically nothing you can individually do about it? I think that's the real question here. Not whether microplastics are harmful. The evidence is pointing pretty clearly in one direction. But what we do with that knowledge? Do we panic? Do we ignore it? Do we just keep going? Because here's the thing about slow motion collapses. They give you time. Time to adapt. Time to push for change. Time to demand that the companies making this stuff actually deal with the consequences. The science is there now. We know what's happening. We're just waiting to see if we'll do anything about it before the damage becomes permanent. And maybe that's the most unsettling part of all. We have the information. We have the warning signs. We're just not sure we have the will to change course. Not when it's this inconvenient. Not when it requires this much effort. So the microplastics keep accumulating. The forever chemicals keep building up. And we keep telling ourselves it'll probably be fine. Until one day, maybe it isn't. You know, we spend so much time worrying about the big dramatic threats. The asteroid strikes, the supervolcanoes, the grid going down. But there's something happening right now that's arguably more dangerous than all of them combined. And we're mostly just ignoring it. The ground beneath our feet is dying. And according to the United Nations, we've got about 60 harvests left before it becomes a real problem. 60 years. That's it. Your kids, if you have them, might live to see a world where we simply can't grow enough food. Let me explain what's actually happening here. Topsoil is the dark, nutrient-rich layer of earth where almost everything we eat comes from. It's only about 8 to 12 inches deep on average, and it takes roughly 500 years to create just 1 inch of it naturally. 500 years for 1 inch. That's how slow nature builds this stuff. But we're losing it about 10 to 40 times faster than it's being replaced. Some estimates say we're down to less than 60 years of viable topsoil left at current rates. The UN's Food and Agriculture Organization has been sounding alarm bells about this for years, but it's not exactly headline news, is it? Here's the thing that really gets me. Industrial agriculture, the system that feeds most of us, is essentially mining the soil. It's extracting nutrients without putting them back. Every time you till a field, you're exposing organic matter to air, which speeds up decomposition. Every time you plant the same crop year after year, you're draining specific nutrients. Every time you use heavy machinery, you're compacting the earth, making it harder for roots and water to penetrate. It's efficient, sure. It produces massive yields. But it's the agricultural equivalent of burning through your savings account and calling it income. And we've seen what happens when this goes wrong. The Dust Bowl in the 1930s wasn't some random natural disaster. It was a direct result of deep plowing of the Great Plains grasslands. Farmers removed the native grasses that had held the soil in place for thousands of years, planted wheat, and when a drought hit, the topsoil just blew away. Massive dust storms, crops failed, families displaced. It was an ecological and humanitarian catastrophe. Now, imagine that happening globally. Because that's what we're headed toward if we don't change course. The really frustrating part is we know how to fix this. Regenerative agriculture isn't some pie-in-the-sky theory. It's being practiced successfully all over the world. Cover cropping, crop rotation, reduced tillage, integrating livestock. These methods actually rebuild soil. They increase organic matter, improve water retention, sequester carbon. There are farmers right now who are restoring degraded land to productivity in just a few years. Places that were nearly desert are growing food again because someone decided to work with the soil instead of against it. But here's the problem. It requires a shift in thinking. Industrial agriculture is optimized for short-term yield. Get as much out of the ground this season as possible. Regenerative agriculture is optimized for long-term sustainability. Build the soil so it's more productive in 10 years than it is today. That's a harder sell when you're competing in a global market and trying to keep your farm afloat this quarter. And let's be honest about why this gets less attention than climate change, even though it's arguably more urgent. Climate change has visible villains: oil companies, emissions, melting ice caps. Soil degradation is invisible. It's slow. It's happening beneath our feet where we can't see it. There's no dramatic footage of topsoil disappearing. It just quietly erodes away, harvest after harvest, until suddenly there's not enough. Plus, we've created a food system where most of us are completely disconnected from where our food comes from. You go to the grocery store, the shelves are full, and you assume they always will be. But every item in that store depends on healthy soil somewhere. The bread, the vegetables, the meat, which ate plants grown in soil. Everything traces back to those few inches of topsoil. And it's not just about quantity. Degraded soil produces less nutritious food. There are studies showing that the vegetables you eat today have significantly fewer vitamins and minerals than the same vegetables 50 years ago. The soil is depleted, so the food is depleted, so we are depleted. It's a cascading problem that touches everything. Here's what keeps me up at night about this. Unlike an asteroid or a supervolcano, this isn't a maybe. This is happening right now, in real time, and we have the solutions. We know what to do. The technology isn't complicated. It's actually simpler than industrial agriculture in many ways. But changing a global food system, that's the hard part. Because soil degradation is what I'd call a boring apocalypse. It doesn't make for good movies. There's no moment where everything suddenly collapses. It's gradual. Each year, the yields are a little lower. Each year, it takes more fertilizer to compensate. Each year, the soil is a little more fragile. Until one day, it's not gradual anymore. The thing is, this problem is solvable. That's what makes it both hopeful and frustrating. We're not waiting for some technological breakthrough. We're not hoping scientists figure something out. We already know how to grow food sustainably. We've just built an entire economic system around doing the opposite. And maybe that's the question we should be asking ourselves. If we know we're running out of topsoil, if we know how to fix it, why aren't we treating this like the emergency it is? Because 60 harvests sounds like a lot until you remember that it's just 60 years. Your grandchildren will be living in that world. The decisions we're making right now about how we treat the soil are deciding whether they'll have enough to eat. It's not dramatic. It's not exciting. But it might be the most important thing we're getting wrong. You know what's terrifying? The idea that a simple cut could kill you. Not because of the cut itself, but because we've run out of ways to fight the infection that follows. That's not science fiction. That's the direction we're heading. Let me paint you a picture. It's 1924. Calvin Coolidge Jr., the president's son, is playing tennis at the White House. He develops a blister on his toe. Within a week, he's dead from a blood infection. The most powerful family in America, with access to the best doctors money could buy, could do nothing. A blister killed the president's son. 4 years later, Alexander Fleming discovers penicillin by accident. A contaminated petri dish changes everything. By the 1940s, we've entered what we now call the golden age of medicine. Suddenly, infections that had killed humans for millennia become treatable. Pneumonia, tuberculosis, infected wounds, they're no longer death sentences. We got comfortable. We got careless. Here's what happened. We started using antibiotics for everything. Got a cold? Have some antibiotics, even though they don't work on viruses. Factory farming needed to grow animals faster and prevent disease in crowded conditions? Just add antibiotics to their feed. By some estimates, about 70% of antibiotics sold in the United States go to livestock, not humans. And bacteria, being the ultimate survivors they are, started fighting back. See, bacteria reproduce incredibly fast. A single bacterium can divide every 20 minutes under the right conditions. That means in a day, one bacterium could theoretically produce more offspring than there are stars in the observable universe. And with each generation, there's a chance for mutation. Most mutations do nothing, but every once in a while, one mutation makes that bacterium resistant to the antibiotic trying to kill it. Now that resistant bacterium has a huge advantage. While all its neighbors are dying, it survives and multiplies. Before long, you don't have a bacterial population anymore. You have a resistant bacterial population. This is happening faster than most people realize. There are already infections out there that laugh at our strongest antibiotics. Carbapenem-resistant Enterobacteriaceae. That's a mouthful, so doctors call them XI, or what's becoming known as nightmare bacteria. They're resistant to carbapenems, which are supposed to be our last line of defense. When someone gets a SIA infection, doctors are sometimes left literally looking through old medical textbooks for antibiotics that nobody's used in decades, hoping to find something that might work. And even then, the mortality rate can be 40% to 50%. Here's what keeps infectious disease doctors up at night. We're starting to see bacteria that are resistant to everything. Pan-resistant bacteria, DE. A few years ago, a woman in Nevada died from a bacterial infection that was resistant to all 26 antibiotics available in the United States. All of them. Think about what that means for medicine. Right now, if you need surgery, even routine surgery like a hip replacement or a cesarean section, you're given antibiotics before, during, and after the procedure. That's because anytime you cut into the body, you risk infection. But those antibiotics work, so we don't worry about it. Without working antibiotics, surgery becomes a gamble. Cancer chemotherapy, which weakens your immune system, becomes too risky. Organ transplants become nearly impossible. We'd be back to a world where doctors are afraid to operate, where a routine procedure could mean a death sentence. This isn't hypothetical. In countries where antibiotic resistance is more advanced, it's already happening. People are dying from infections after routine surgeries that would have been completely survivable a decade ago. And here's the cruel irony. Just when we need new antibiotics most, pharmaceutical companies are backing away from developing them. Why? Because antibiotics are a terrible business model. Think about it. If a company develops a new antibiotic, doctors will save it as a last resort to slow down resistance, so it doesn't get prescribed much. Compare that to a blood pressure medication, which patients might take daily for decades. From a business perspective, it makes no sense to invest billions in developing an antibiotic that will intentionally be used as little as possible. So companies are walking away. Between 1980 and 2021, multiple major pharmaceutical companies shut down their antibiotic research programs entirely. We're losing the drugs we have, and we're not making new ones to replace them. So what did medicine look like before antibiotics? It's hard for us to imagine now, but it was brutal. Minor injuries were serious concerns. Women died in childbirth from infections at staggering rates. A scratch from a rose thorn could lead to an amputation. Surgery was avoided whenever possible because the infection risk was so high. The average life expectancy in the United States in 1900 was about 47 years. By 2000, it was 77. Antibiotics aren't the only reason for that change, but they're a major part of it. And we're potentially throwing it all away. There are solutions, but they require us to change how we think about antibiotics. We need to stop using them in agriculture the way we do. We need doctors to prescribe them only when truly necessary. We need patients to stop demanding them for viral infections they won't help. We need governments to incentivize antibiotic development, even though it's not profitable. But most of all, we need to stop thinking of antibiotics as an infinite resource. They're not. They're more like a non-renewable resource that we've been burning through without thinking about what happens when they're gone. The strange thing is, we saw this coming. Scientists have been warning about antibiotic resistance since the 1940s. Fleming himself warned about it in his Nobel Prize speech. But warnings about slow-moving catastrophes are easy to ignore, especially when the solution requires sacrifice and coordination on a global scale. It's a lot like climate change in that way, actually. We know what's happening. We know what we need to do. But the incentives are all wrong, and the timeline feels just distant enough that we keep putting it off. Except with antibiotic resistance, the timeline might be shorter than we think. The World Health Organization has called it one of the biggest threats to global health today. They estimate that by 2050, antibiotic-resistant infections could kill 10 million people per year, more than currently die from cancer. That's not a maybe. That's where we're headed unless something changes. So, the next time you get a prescription for antibiotics, take all of them, exactly as prescribed. Don't save them. Don't share them. Don't demand them for a cold. Because every time we use antibiotics, we're rolling the dice, creating pressure for bacteria to evolve resistance. We're in a race. And right now, the bacteria are winning. You know, it's funny how we think about climate change. We picture rising seas, melting ice caps, stronger hurricanes. But there's something else happening beneath the surface of the ocean. Something that's been running like clockwork for thousands of years. And it's slowing down. I'm talking about the ocean conveyor belt. Scientists call it the Atlantic Meridional Overturning Circulation, or AMOC for short. Let's just stick with conveyor belt though, because that's genuinely what it is. Picture this. There's a massive river flowing through the ocean. It's not separate from the ocean. It is the ocean, but it moves differently than the water around it. Warm water flows north along the surface, carrying heat from the tropics up toward Europe. When it reaches the Arctic, it cools down, becomes denser, and sinks to the bottom. Then it flows back south along the ocean floor, completing this enormous loop. This isn't a small thing. We're talking about moving more water than all the world's rivers combined. Every single day. And here's what matters. That warm water flowing toward Europe? It's why London has milder winters than parts of Canada that are actually farther south. It's why Norway can have ice-free ports in the Arctic Circle. The Gulf Stream, which is part of this whole system, is essentially a giant heating system for Western Europe. But it's breaking down. The evidence started showing up in the data about 15 years ago. The conveyor belt is moving slower than it has in over 1,000 years. Current estimates suggest it's weakened by about 15% since the mid-20th century. Some studies say it could slow by another 40% this century. So what's causing this? Well, remember all that ice melting in Greenland? That's not just raising sea levels. It's pouring massive amounts of fresh water into the North Atlantic. Fresh water is less dense than salt water. It doesn't sink as readily. And if the water doesn't sink, the whole conveyor belt loses its engine. It's like putting a kink in a hose. The water's still flowing, but not like it should. Now, you might be thinking, wait, if global warming is making things hotter, wouldn't a cooling effect in Europe be a good thing? That's actually one of the really cruel ironies here. Europe might get colder while the rest of the planet heats up. We're not talking about pleasant cooling either. We're talking about the kind of cold that makes it hard to grow food. There's a movie about this, remember? The Day After Tomorrow. Giant tidal waves, New York freezing over in minutes, people outrunning the cold. It's entertaining, but it's not really how this would happen. Hollywood compressed everything into a few days. In reality, we're talking about changes over years or decades, not hours. But that doesn't make it less serious. It might actually make it more dangerous, because slow changes are easier to ignore until it's too late. If the amok shuts down completely, and that's a real possibility within this century, here's what happens. Average temperatures in Europe could drop by 5 to 10 degrees Celsius. That might not sound like much, but that's the difference between being able to grow wheat and not being able to grow wheat. That's the difference between rain and snow in October instead of December. Ireland, Scotland, parts of England that are currently green and fertile, they'd start looking a lot more like northern Canada. Agriculture would have to completely reorganize. Entire crops would fail. Millions of people would need to relocate. And it's not just Europe. When you mess with the ocean conveyor belt, you mess with weather patterns globally. The monsoons in India and Africa depend on ocean temperature differences. Disrupt those, and you're talking about droughts affecting billions of people. Rainfall patterns would shift across the Americas. Fisheries would collapse as marine ecosystems struggle to adapt. This is what scientists mean when they talk about a tipping point. It's not a gradual, steady change. It's a system that stays stable until it doesn't. Like a light switch, not a dimmer. The terrifying part. We might not know we've passed the tipping point until it's already happened. The ocean moves slowly. By the time we see the full effects, the cause happened years earlier. There's no undo button here. Some scientists think we still have time. Others think we might have already triggered the collapse, and we're just waiting for it to play out. The data's complex and the models aren't perfect. But the trend is unmistakable. The conveyor belt is weakening, and it's weakening faster than our models predicted even a decade ago. There's this uncomfortable question lurking underneath all of this. What if we've already lost? What if the changes we've made to the atmosphere and oceans have already set in motion something we can't stop? I don't have a comforting answer to that. Nobody does, really. But here's what we do know. The slower we act on climate change, the worse this gets. Every fraction of a degree of warming we prevent, every ton of ice we keep from melting, buys us time. Maybe enough time to adapt. Maybe enough time to find solutions we haven't thought of yet. The ocean conveyor belt has been running for over 10,000 years, since the end of the last ice age. It's shaped human civilization in ways we barely understand. The stability it's provided has allowed us to build cities, develop agriculture, create everything we think of as modern life. And we're watching it wind down. It's like discovering your car's engine is failing while you're still on the highway. You can keep driving for a while. Everything seems fine, but you know what's coming. The question isn't whether you'll have to deal with it. The question is whether you'll pull over now or wait until you break down in the middle of nowhere. We're still on the highway. The engine's still running. But that sound you're hearing, that's not normal. And it's getting louder. But here's the thing about all these warnings, all these signals. They're not just happening to us. We're not passive victims watching the world unravel. Because here's what we forget. Every generation inherits the consequences of what came before, and every generation plants seeds for what comes next. And right now, we're doing both at the same time. Let's talk about karma for a second. Not the mystical version, but the practical one. The word literally means action, and every action creates ripples we can actually measure. Plant a tree, you've changed the temperature of that spot. Cut down a forest, you've altered rainfall patterns thousands of miles away. It's not spiritual. It's physics. There's a man in India named Yadav Payeng who understood this better than most scientists. In 1979, when he was just 16 years old, He found a sandbar near his village, completely barren, baking in the sun, nothing growing. And he started planting trees. Every single day. For 40 years. Nobody asked him to do this. Nobody paid him. His neighbors probably thought he was wasting his time. But Payne kept planting. Bamboo first, because it grows fast and holds the soil. Then other species. He'd water them, protect them, plant more. Year after year. Today, that sandbar is a 550-hectare forest. Tigers live there now. Rhinos, toy. Elephants. An entire ecosystem emerged because one person refused to accept that dead land stays dead. The forest is so large, it shows up on satellite imagery. One man did that. Or take Wangari Maathai in Kenya. In the 1970s, she noticed something. As forests disappeared, women had to walk farther for firewood. Rivers were drying up. Soil was washing away. So she started the Greenbelt movement, teaching women to plant trees. Not for environmental activism, though that's what it became. For survival. Those women planted 51 million trees. 51 million. And it changed everything. The soil held. Water came back. Communities that were on the edge of collapse stabilized. Maathai won the Nobel Peace Prize in 2004, but the real prize was the causality she proved. Trees hold soil, soil absorbs water, water prevents floods, communities survive. It's that direct. Here's what most people don't know about forests. They create their own rain. Through transpiration, trees release water vapor that forms clouds. Those clouds move. They rain. They feed other forests. Scientists call these atmospheric rivers. The Amazon rainforest, for example, doesn't just benefit from rain, it generates it. That moisture travels, affecting weather patterns across South America and beyond. Which means when you deforest the Amazon, you're not just removing trees. You are shutting off a pump that's been running for thousands of years. Rainfall decreases in Brazil, then in Argentina, then in Africa. Then crops fail in places that seem completely unconnected. The causality isn't instant, but it's inevitable. That's the reverse side of karma that we're experiencing right now. We're harvesting what previous generations planted. The Industrial Revolution, the Green Revolution, the clearing of forests for farmland. All those actions created ripples. And now the wave is reaching us. But here's the crucial part. It works both ways. Right now, across Africa, they're building the Great Green Wall, an 8,000-kilometer barrier of trees stretching from Senegal to Djibouti, designed to stop the Sahara Desert from expanding further south. It sounds impossible, right? Holding back a desert with trees. Except it's working. In Niger, there's something called FARMA, Managed Natural Regeneration. Basically, instead of planting new trees, farmers protect and nurture the root systems still in the ground from old forests. They prune them, manage them, let them regrow. In 30 years, they've restored 5 million hectares of land that was turning into desert. 5 million hectares that now grow food, hold water, support livestock. The trees came back because people decided they should. That's it. No massive technology. No billion-dollar investment. Just the decision to stop cutting and start protecting. And this isn't charity. This isn't feel-good environmentalism. This is investing in the atmospheric system that keeps us alive. When those trees grow, they stabilize soil. They regulate temperature. They create microclimates where food can grow. They're not decorative. They're functional. They're infrastructure. The same thing's happening with community seed banks. All over the world, people are saving seeds, heirloom varieties, local crops, plants adapted to specific conditions. Because they understand that genetic diversity isn't abstract. It's insurance. If one crop fails, you need options. If the climate shifts, you need seeds that can handle it. This is karma in action. Save seeds today, eat tomorrow. Protect soil now, grow food later. It's the long-term thinking we've forgotten in a world obsessed with quarterly profits and instant results. Regenerative agriculture works on the same principle. Instead of depleting soil with chemicals and monocultures, you enrich it. Cover crops, crop rotation, composting, techniques that have been around forever but got abandoned because they're slower than industrial farming. Except here's the thing, they work. The soil gets healthier every year instead of more exhausted. Yields stay stable. The land becomes more resilient. It's the opposite of what we've been doing, which is essentially mining the soil, extracting nutrients faster than they can regenerate. And we wonder why we're running out. The uncomfortable truth we have to face is this: we are living off what previous generations planted. The forests they protected. The soil they enriched. The systems they maintained. And simultaneously, we're determining what our grandchildren will inherit. The depleted oceans. The plastic-saturated environment. Or maybe the restored forests. The healthy soil. The stable climate. It's not metaphorical. It's literal. What you plant today, whether it's an actual tree or a habit or a system, that's what grows tomorrow. And if all those warning signs we talked about, the signals, the crises, the collapsing systems, if those are real, then this matters more than ever. Because maybe the reset isn't some external disaster we're waiting for. Maybe it's a choice. The choice to stop extracting and start replenishing. To stop consuming and start planting. Not because we'll see the full results. Payne planted trees for 40 years before he had a forest. The people planting the Great Green Wall won't live to see it finished. That's the point. You plant trees for shade, you'll never sit under. You save seeds for gardens, you'll never tend. That's what makes it matter. Because the alternative, the path we're on, that's a harvest too. Just a different kind. So let's talk about your refrigerator. It's smart now, right? Knows when you're low on milk. Maybe suggests recipes based on what's inside. Convenient. Except here's the thing. That refrigerator is also connected to the internet. And anything connected to the internet can be hacked. In 2016, something called the Mirai botnet pulled off one of the strangest cyber attacks in history. It didn't target banks or governments. It targeted everyday devices. Baby monitors. DVRs. Security cameras. Hundreds of thousands of them. These devices were turned into an army, a botnet, and they all attacked at once, flooding major websites with traffic until they crashed. Twitter went down. Netflix, Reddit, Twitch, big chunks of the internet just stopped working. And it happened because someone figured out that most smart devices ship with default passwords that nobody bothers to change. Your refrigerator, your doorbell, your thermostat, they all have the same vulnerability. We've built this incredible web of connected things. The Internet of Things, they call it. Your car talks to your phone. Your watch talks to your TV. Your home security system can be controlled from halfway around the world. It's supposed to make life easier. And it does, until it doesn't. Because here's what we've actually done. We've given every device in our lives an internet connection, and we've assumed that convenience and security can coexist. They can't. Not easily. Every connection is a doorway. Every doorway can be opened. Think about smart cities for a moment. Traffic lights that adjust to traffic flow. Power grids that balance load in real time. Water systems monitored by sensors. It's efficient. It saves energy. But if someone hacks into that system, they don't just get data, they get control. They could shut down traffic lights during rush hour, manipulate power distribution to cause blackouts, contaminate water supplies by changing chemical levels at treatment plants. This isn't theoretical. In 2021, someone hacked into a water treatment facility in Florida and tried to poison the water supply by remotely increasing sodium hydroxide to dangerous levels. Luckily, an operator noticed and stopped it. But the hacker had access. They got in. And that facility wasn't unique. It was just the one where someone got caught. Or, consider your car. Modern vehicles are computers on wheels. They have dozens of systems talking to each other. Brakes, steering, acceleration, all controlled by software. Some can receive over-the-air updates, just like your phone, which means they can receive other things too. Security researchers have demonstrated they can remotely take control of cars, disable brakes, cut engines, override steering. It's been done in controlled tests, which means it can be done in the real world. And the more we automate, the more vulnerable we become. Self-driving cars will need to communicate with each other, with traffic systems, with infrastructure. That's thousands of connection points, thousands of potential vulnerabilities. One compromised system could theoretically cause crashes across an entire city. But here's where it gets really fragile. Our entire modern economy runs on something called just-in-time delivery. Stores don't stockpile goods anymore. Warehouses don't hold months of inventory. Everything is calculated to arrive exactly when it's needed. It's efficient. It cuts costs. It also means there's no buffer, no margin for error. Your grocery store has maybe 3 days of food on hand. Hospitals have similar timelines for medicine. Gas stations get deliveries every few days. This works because it's all coordinated through digital systems. Trucks talk to warehouses. Warehouses talk to suppliers. It's a choreographed dance happening in real time, all managed by software. If that software stops working, even for a week, shelves go empty. Not gradually. Fast. We saw glimpses of this during COVID. One disruption, and suddenly, there's no toilet paper. Now imagine that disruption is intentional, coordinated. Someone attacking the logistics networks that keep goods moving. You wouldn't need to attack the entire system. Just key points. The Port of Los Angeles handles 40% of containerized goods coming into the United States. Hack their management systems, and you've created a bottleneck that backs up for months. Or target payment systems. If credit cards stop working, how do transactions happen? Cash? Most people don't carry enough cash to buy a week's worth of groceries. The terrifying part is how dependent we've become without realizing it. 30 years ago, if the internet went down, life continued. People had phone books, paper maps, cash, handwritten records. Now, your bank exists primarily as data. Your money is numbers on a screen. Your medical records are in the cloud. Your car needs software updates to keep running. We've created this house of cards, and we're still stacking it higher. And the people building these systems, they're not thinking about security first. They're thinking about features, convenience, getting products to market fast. Security is expensive. It's complicated. It slows things down. So devices ship with vulnerabilities, with default passwords, with software that's never updated. And we buy them because they're convenient. Your smart doorbell might let you see who's at your door from anywhere in the world. It might also let someone else see inside your house. Your fitness tracker knows where you run every morning. That data gets sold to advertisers, but it could just as easily be used by someone planning a burglary. They'd know exactly when you're not home. We're generating data constantly about our habits, our routines, our locations. And we're trusting that this data stays secure, even though breaches happen all the time, even though companies get hacked, even though our information ends up for sale on the dark web. The Internet of Things isn't just vulnerable to hackers. It's vulnerable to failures, software bugs, power outages, one cascading error taking down interconnected systems. And we've built our entire infrastructure on the assumption that these systems will keep working. that nothing will go seriously wrong. But something will. Maybe it's a cyber attack. Maybe it's a solar flare that fries electronics. Maybe it's just a really bad software update that bricks millions of devices at once. The specific cause doesn't matter as much as the reality. We've made ourselves dependent on technology we don't fully control and can't easily fix. So what do? You can't exactly disconnect. You need your phone, your computer. The internet is woven into everything now. But maybe you don't need your refrigerator to be smart. Maybe you keep some cash on hand. Maybe you know how to navigate without GPS. Maybe you remember phone numbers instead of relying on contacts you'd lose if your phone died. Small things. But they're buffers, redundancies, ways to keep functioning when the house of cards wobbles. Because it will wobble. The question isn't if, it's when and how hard. Let's talk about what collapse actually looks like. Not in movies, not in theories, but in real countries where it's happening right now. Because here's the uncomfortable truth. Societal collapse isn't always dramatic. Sometimes it's just Tuesday nightmare. Then Wednesday. Then suddenly you're standing in line for bread, wondering how everything fell apart. Venezuela is the textbook example everyone should be studying. In 2012, Venezuela had the largest oil reserves in the world. It was a functioning, modern country. People had jobs, ate out at restaurants, planned vacations. Just like you probably did last week. By 2019, just 7 years later, people were eating zoo animals to survive. Hospitals ran out of basic supplies like antibiotics and anesthesia. Inflation hit 1,000,000%. A million. The currency became literally worthless. People stopped counting it and just waited instead. Here's what's terrifying. If you'd asked a Venezuelan in 2012 if their country could collapse, they'd have laughed at you. The timeline matters because it shows how this actually unfolds. It wasn't one catastrophic event. It was a series of that's weird moments that slowly became this is fine moments, until suddenly nothing was fine anymore. First, certain products disappeared from shelves. Then lines got longer. Then, the government started rationing. Then, the rationing stopped working. Each step felt manageable, temporary, even, until it wasn't. Sri Lanka followed a similar pattern, just faster. In early 2022, it was a functioning country. By mid-2022, it had completely run out of fuel. The government collapsed. People stormed the presidential palace, not in revolution, but in desperation, looking for solutions that weren't there. Lebanon's been in freefall since 2019. Banks frozen. Currency collapsed. Electricity for maybe 2 hours a day. Hospitals closing because they can't get supplies. This is happening right now, while you're listening to this. What's haunting is how normal these places looked just before. There are YouTube videos from Caracas in 2013, Colombo in 2021, Beirut in 2018. They look like any city. People going to work, traffic jams, kids in school. The mundane stuff that makes up daily life. That's what collapse actually looks like at first. It looks like nothing's wrong. The stages follow a predictable pattern. Denial comes first. People tell themselves it's temporary. The government says everything's under control. The news minimizes it. Everyone convinces themselves they're overreacting. Then panic hits. But here's what people get wrong about panic. It's not everyone rioting in the streets. It's quiet panic. It's hoarding toilet paper. It's pulling cash from banks. It's hundreds of small, rational decisions that collectively create the crisis they were trying to avoid. Then comes adaptation, which sounds positive, but isn't. It's people learning to live with less. Way less. It's doctors performing surgery without anesthesia. It's kids doing homework by candlelight. It's redefining what counts as normal, until you forget there was ever anything else. Survivors from these collapses all say the same thing. I wish I'd taken it seriously sooner. Not in a doomsday prepper way. They mean simpler things. They wish they'd kept cash at home, learned to fix things, built stronger relationships with neighbors, stored some basics, had a backup plan. But most of all, they wish they'd trusted their gut when things first felt off, instead of waiting for permission from the news or the government to acknowledge that yes, something was actually wrong. There's this concept in systems theory called slow motion collapse. It's when the breakdown happens gradually enough that each generation adapts to a slightly worse normal, never realizing how far things have fallen. Your grandparents might have owned a home on a single income. Your parents needed 2 incomes for the same lifestyle. You need 2 incomes plus side hustles just to rent. Each generation adapts. Each generation thinks this is just how things are now. But zoom out, and you can see the trajectory. That's what makes modern collapse different from historical examples. Rome fell over centuries. The Bronze Age collapse took decades. But Venezuela went from functional to failed in under a decade. The speed is accelerating because our systems are more interconnected and therefore more fragile than ever before. Here's the thing about it's always gradual, then sudden. People misunderstand this. They think it means nothing happens for a long time, then everything happens at once. But that's not quite right. The collapse is happening the whole time. Gradually. You're just not calling it collapse yet. You're calling it these uncertain times or the challenging economy or unprecedented weather. You're adapting, coping, making do. Then one day, you can't anymore. And that's when it becomes sudden, not because the collapse just started, but because you finally ran out of ways to adapt to it. Venezuela ran out of ways to adapt when the water stopped flowing. Sri Lanka hit that point when the fuel ran out. Lebanon reached it when the banks froze everyone's savings. The question for wherever you're listening from is, what would your breaking point be? How many services would have to fail before normal couldn't be maintained anymore? For most developed countries, it's about 3 days. That's how long the average city has in food supplies if trucks stop delivering. 3 days before the store shelves are empty. Not because of panic buying, though that accelerates it, but because modern supply chains are designed to be efficient, not resilient. Just-in-time delivery means there's no buffer, no slack, no room for error, which is great for profits until something breaks. Then, it's catastrophic. The people who've lived through collapse aren't paranoid doomsday preppers. They're regular people who learn the hard way that it can't happen here is just denial with better marketing. And maybe that's the most important lesson from Venezuela, Sri Lanka, Lebanon, and everywhere else it's happening. It can happen anywhere. Because these weren't failed states to begin with. They were functioning countries that made some bad decisions and couldn't recover before the cascading failures took over. You know what's really keeping sociologists up at night? It's not that collapse could happen. It's how many places are already in the gradual phase and don't realize it yet. You'd think after looking at all these potential collapse scenarios, the supervolcanoes, the failing antibiotics, the dying soil, that more people would be preparing. But most of us aren't. We go about our days, order takeout, scroll through our phones, and the thought of keeping extra water in the garage feels almost embarrassing. There's actually a psychology to this. And understanding why we don't prepare might be the first step toward actually doing something about it. It's called normalcy bias. It's the brain's tendency to believe that things will continue functioning the way they always have. Even when you see the warning signs, even when the data's right in front of you, your brain keeps insisting, this is fine. Everything's always been fine. It's why people don't evacuate before hurricanes even when they're told to. It's why we watched COVID spread across the world and still thought it wouldn't reach our neighborhood. We are wired to assume tomorrow will look like today. And here's the thing. Most of the time, that assumption's correct. That's what makes normalcy bias so dangerous. It works right up until it doesn't. Your brain's running on pattern recognition, and the pattern it knows best is wake up, go to work, come home, repeat. The pattern doesn't include societal collapse, so your brain just doesn't believe it's possible, even when you intellectually know better. Then there's the bystander effect, but scaled up to civilization. You know how if someone collapses on a busy street, everyone assumes someone else will help. That's happening with our global problems. Climate change, soil degradation, antibiotic resistance. These are massive, complex issues, and we're all kind of looking around thinking, surely somebody's handling this. The government, scientists, somebody. And because we assume others are taking responsibility, we don't take it ourselves. The truth is, a lot of people in positions of power are also looking around, assuming someone else has a plan. It's bystanders all the way up. Everyone's waiting for someone else to act first, and meanwhile, the person who collapsed is still lying on the ground. Now let's talk about why prepping became a dirty word. If you mention you're stockpiling food or learning survival skills, people think you're paranoid. Maybe they picture someone in a bunker wearing a tinfoil hat. The social stigma around preparing is real, and it's powerful. Nobody wants to be that person, the one who's overreacting, who's too worried, who can't just relax and trust that things will work out. But here's what's dangerous about that stigma. It keeps us from doing basic, reasonable things that aren't paranoid at all. Having a week's worth of food, knowing first aid, understanding how to purify water. These aren't extreme measures. These are just practical. They're the kind of things your grandparents probably knew how to do without thinking twice about it. Somewhere along the way, self-sufficiency became suspicious instead of sensible. Part of it's because true self-sufficiency threatens consumer culture. If you can grow your own food, fix your own stuff, and don't need constant purchases to feel secure, you're not a very good customer. There's an economic interest in keeping people dependent and unprepared. That's not a conspiracy theory. It's just how the system's designed. There's also something called learned helplessness. It's a psychology term that came from some really grim experiments where animals were put in situations they couldn't escape, and eventually they just stopped trying. Even when escape became possible, they'd given up. And you can see this in humans too. When problems feel too big, too complex, too far beyond your control, it's easier to just accept them. What can I do about climate change? I'm just one person. That's learned helplessness talking. The flip side is learned agency, the belief that your actions matter, that you can influence outcomes. And the interesting thing about agency is that it builds on itself. You start small. Maybe you learn to grow tomatoes. Then you realize you can grow other things. Then you're teaching your neighbor. Then you're part of a community garden. Each small success teaches your brain, I can do things. I'm not helpless. That shift in mindset matters more than almost anything else. But here's where it gets tricky. There's a difference between preparedness and anxiety. Anxiety's when you're lying awake at 3 in the morning, imagining every worst-case scenario and feeling paralyzed. Preparedness is when you calmly think through what you'd need if the power went out for a week, and then you get those things. One makes you helpless. The other makes you capable. The problem is, they can feel similar. Both involve thinking about bad things that might happen. But anxiety loops. It circles back on itself, gets bigger, feeds on itself. Preparedness has an endpoint. You make a plan, you gather supplies, you learn a skill, and then you're done. You can move on with your life, except now you're more secure. A lot of people avoid preparing because they're afraid it'll make them anxious. They don't want to think about disasters, so they just don't. But actually, the reverse is true. Not preparing is what creates anxiety, because deep down, you know you're vulnerable. Every news story about a crisis hits harder when you know you'd have no idea what to do. Preparing isn't what makes you anxious. Being unprepared is what makes you anxious. There's also something called optimism bias. We tend to think bad things happen to other people, not us. Sure, that town got hit by flooding, But it won't happen here. Those people lost everything in the wildfire, but I'm not in a fire zone. We draw arbitrary lines around ourselves and assume the bad stuff stops at the border. It's a comfort mechanism. And most of the time, we're right. Bad things usually do happen to someone else. But eventually, for some of us, we become the someone else. So why do we keep not preparing? Because it's uncomfortable. Because it forces us to imagine a future that's worse than the present. Because it's easier to believe that someone else will handle it, that the systems will hold, that we'll be fine like we've always been fine. Because preparing means admitting that the world might change in ways we can't control. And that's scary. But here's the thing nobody tells you. Preparing makes it less scary. Once you've done the work, once you've learned the skills, built the connections, gathered the supplies, you stop worrying so much. Because you know you could handle it. Not everything, obviously, but enough. The psychology of not preparing is, in the end, about fear. Fear of looking foolish. Fear of wasting effort on something that might not happen. Fear of facing how fragile our systems really are. But all that fear does is keep you frozen. And frozen isn't the same as safe. It's just the illusion of safety, right up until the moment it isn't. Maybe the question isn't why people don't prepare. Maybe the question is, what would it take for you to start? But here's the thing about preparing. It doesn't have to mean stockpiling ammo and canned beans in a basement. That Hollywood version of prepping misses the entire point. The strongest predictor of who survives a crisis isn't how much stuff they've hoarded. It's how connected they are to their community. There's actual data on this. After Hurricane Katrina, researchers studied which neighborhoods recovered fastest. It wasn't the wealthiest ones. It was the neighborhoods where people knew each other's names, where someone had a chainsaw and knew how to use it, where the retired nurse still remembered her training, where people had skills and, more importantly, were willing to share them. That's what real resilience looks like. Not bunker. A neighborhood. And you don't need to be an expert at everything. You just need to be useful at something. Can you grow tomatoes? Fix a bike? Purify water? Treat a wound? These aren't exotic survival skills. They're basic human competencies we've outsourced to specialists and supply chains. Think about it. How many things do you use every day that you couldn't repair if they broke? How many meals could you make if the grocery store closed for a month? It's not about paranoia. It's about agency. There's a movement called transition towns that gets this right. Started in a small town in England, it spread to thousands of communities worldwide. The idea is simple. Start building local resilience now, before you need it. Community gardens, tool libraries, skill shares, repair cafes where people teach each other how to fix things instead of throwing them away. These aren't fringe survivalist compounds. They're normal people in normal towns asking a smart question. What happens if the things we depend on become unreliable? And then, actually doing something about it. One transition town in Totnes, England, even created their own local currency to strengthen the local economy. Another in Boulder, Colorado, mapped every fruit tree in town so residents could harvest food during shortages. These are elegant solutions, practical, and they make life better right now, not just in some theoretical disaster. Because here's what a lot of preppers get wrong. They prepare for the wrong thing. They imagine a sudden dramatic collapse. Society ends on a Tuesday, but real crises are usually slower. Messier, it's not that the grocery store closes forever. It's that prices double, then triple. Supply chains stutter. Some things disappear from shelves for weeks at a time. What you need isn't a bunker full of supplies. What you need is a community where someone kept chickens, someone else knows which plants are edible, and someone remembers how people used to preserve food before refrigeration existed. Your neighbors matter more than your stockpile. And I know that's a hard sell in a culture that's trained us to see self-sufficiency as the ultimate goal. We don't borrow sugar anymore. We don't ask for help. We order everything online and interact with our neighbors through Ring doorbells. But isolation is the opposite of resilience. There's this uncomfortable truth about disasters. They reveal what was already broken. The communities that fall apart in a crisis were already fragmented. The systems that fail catastrophically were already fragile. You can't build resilience after the disaster starts. You build it now in the boring times, when it feels unnecessary. So what does that actually look like? Start small. Introduce yourself to a neighbor you've never spoken to. Join a community garden, or start one. Learn first aid, real first aid, not just CPR certification you forget immediately. Take a wilderness medicine course. Learn to preserve food. Grow something, even if it's just herbs in a window box. Not because you think you'll need to survive off your basil plants, but because the act of growing food reconnects you to how food actually works. Learn to repair things. Mend your own clothes. Fix your bike. Sharpen a knife. These skills sound trivial until they're not. And here's the interesting part. These things make your life better right now. Food you grow yourself tastes better. Clothes you repair yourself last longer. Communities where people know each other are measurably happier, healthier, safer. You're not preparing for the apocalypse. You're just choosing to live in a way that isn't completely dependent on systems you can't control. There's a concept in ecology called redundancy. Healthy ecosystems have backup systems. Multiple species doing similar jobs. If one fails, others compensate. That's resilience. Modern life has eliminated redundancy in the name of efficiency. Just-in-time delivery. Specialized skills. Global supply chains with no slack in them. It works brilliantly until it doesn't. Building personal resilience means adding redundancy back into your life. Not one way to get food, but several. Not one skill set, but many. Not isolated self-sufficiency, but a web of relationships and capabilities. And you don't have to do everything. That's the beauty of community resilience. You grow vegetables, I'll keep bees. You know carpentry, I know plumbing. You teach my kids first aid, I'll teach yours how to forage. We become resilient together, not alone. This isn't radical. It's how humans lived for thousands of years. The radical thing is how quickly we forgot. So maybe preparing isn't about anticipating a specific disaster. Maybe it's about acknowledging that complex systems are fragile and choosing to be less dependent on them. Not out of fear, out of common sense. And maybe, just maybe, if enough people start doing this, we make the whole system more resilient. We create communities that can handle disruption. We build networks that don't collapse when one link fails. The crisis might not come. I hope it doesn't. But if it does, the people who'll be okay aren't the ones with the most supplies. They're the ones who know how to adapt, how to cooperate, and how to make do with what they have. They're the ones who built resilience while everyone else was building bunkers. So why do we do this to ourselves? Why do we watch the disaster movies, read the apocalypse novels, listen to podcasts about the end of everything? There's something almost comforting about it, isn't there? And that's not as strange as it sounds. Think about your daily life for a moment. You're juggling work deadlines, family obligations, bills that need paying, emails that need answering. You're worried about your career, your health, your relationships. You're trying to figure out if you should change jobs, move cities, fix that thing that's been broken for months. It's complicated. It's exhausting. It's 1,000 small decisions that never quite feel resolved. Now imagine all of that just stops. The world resets. Suddenly, the only question is, survive or don't. Feed yourself. Find water. Stay warm. Connect with the people around you. It's terrible, yes. But it's also simple. That's the strange appeal of apocalypse stories. They cut through all the noise. They erase the complicated, frustrating parts of modern life and replace them with something primal and clear. You don't have to worry about your 401k in the zombie apocalypse. You don't have to attend pointless meetings after the asteroid hits. All those things that felt so important yesterday don't matter anymore. There's a weird relief in that, a fantasy of starting over. And maybe that tells us something important about how we're living right now. When collapse scenarios feel comforting, maybe it's because we're already feeling broken in some way. When we fantasize about everything ending, maybe it's because we can't figure out how to fix what we've got. But here's what actually happens when you start preparing for the worst. You stop worrying so much. That sounds backwards, doesn't it? But it's true. When you learn first aid, when you build community connections, when you gain practical skills, something shifts. You're not anxiously wondering what if anymore. You're calmly thinking, if this happens, I'll do that. It's the difference between dread and readiness. Buddhism talks about this. Not the reset, but impermanence. Everything changes. Everything ends. Your life, my life, civilizations, species, planets, stars. Nothing lasts forever. And weirdly, accepting that doesn't make you hopeless. It makes you present. When you truly accept that nothing's permanent, you start noticing what's here right now. You taste your coffee. You look at the sky. You appreciate the conversation you're having, the meal you're eating, the ordinary Tuesday that might seem boring, but is actually kind of miraculous when you think about it. The reset we're worried about? It's already happening. Just slowly. Every day, some part of the world we knew disappears. A species goes extinct. A glacier melts. A skill gets forgotten. A language stops being spoken. Things are always ending. Things are always beginning. Maybe the real question isn't what if everything collapses. Maybe it's how do I want to live while things are changing. Because here's the truth. You get to choose. Right now. Not in some future crisis, but today. You can choose to build skills instead of buying stuff. You can choose to know your neighbors instead of just passing them in the hallway. You can choose to grow something, fix something, make something, teach something. You can choose to be the kind of person who makes things more resilient instead of more fragile. That's not about doomsday prepping. That's just about being a human being who's awake to reality. Fatalism says it doesn't matter what I do. Everything's doomed anyway. Acceptance says I can't control everything, but I can control this one thing right here. That difference is everything. The strange comfort of endings isn't really about wanting the world to end. It's about wanting the weight of this particular world to lift. The pressure, the complexity, the feeling that we're trapped in systems we didn't choose and can't change. But you know what? You don't need an apocalypse for that reset. You can reset your own life. Today, right now, you can decide that you're done living like you're immortal, and this is all permanent. You can decide that you're going to learn that skill, have that conversation, take that risk, make that change. You can decide that you're going to stop waiting for permission or the perfect moment or until you figure everything out. The world might reset. It might not. Either way, you're here now. And now is when you get to decide who you're going to be. Maybe that's what all of this has really been about. Not preparing for some distant collapse, but waking up to the collapse that's already happening and choosing how to respond to it. Not with panic or denial, but with intention. So here's my question for you, and it's the same question I've been asking myself. If everything reset tomorrow, what would you want to rebuild? Really think about it. Not just systems and infrastructure, but ways of living, ways of connecting, things that actually matter. Because here's the secret, you can start building that now. You don't have to wait for everything to fall apart to start putting together something better. Maybe the reset isn't coming from outside. Maybe it's something we choose. A reset in how we think, how we live, how we treat each other and the planet we're standing on. The world's going to change. That's the only guarantee. But how it changes, what we build while it's changing, who we decide to be in the middle of uncertainty, that's still up to us. And maybe that's not comfortable. Exactly. But it's something better than comfort. It's possibility. Thanks for listening. And whatever comes next, I hope you're ready.